For second partial derivatives, all of our derivative properties still apply. Everything we've been doing in the first few examples still carries forward to the first half of these problems, or the first third of these problems. And then in the next two parts, what we'll do is look at taking the second derivative, again paying very close attention to which variable we're differentiating with respect to. So in part A, for example 6, we'll start off by finding m sub x, meaning we're taking the first derivative with respect to x, meaning we're taking the derivative of negative 3xy, and we're differentiating that with respect to x. So we'll end up with negative 3 times the derivative of x will just be 1 times y, or negative 3y. In part B, we want to find m sub xx, which means we want to start with the first derivative with respect to x, that result that we just found, and now take the derivative again with respect to x. So we'll be taking the derivative of negative 3y with respect to x. Since there is no x factor in that term, we treat it all as a constant, so that derivative just becomes 0. In part C, we want to find m sub xy, meaning we're taking the first derivative with respect to x, that result we found in part A, but now for the second derivative, we'll differentiate with respect to y. That means we'll find the derivative of negative 3y, this time with respect to y, which will give us negative 3 times 1, or just negative 3. In example 7, we again want to find the first derivative, this time with respect to y, meaning we'll find r sub y, which will be equal to 2e to the negative 2x minus 4y times the derivative of that interior function, meaning we're applying the chain rule, and we're differentiating that interior function with respect to y. So the first part of this remains unchanged. And then differentiating that interior function with respect to y would give us 0, since there's no y factor in that first term, minus 4 times 1, or just 4. Then we can take negative 4 times 2 to give us negative 8, e to the negative 2x minus 4y as our final result for that first derivative. To find m sub yy, I mixed up my letters there, but these should all be referencing the same function. This should still be r. So we're taking the first derivative with respect to y, meaning we're taking that result from part A, and now taking the second derivative with respect to y, and that derivative will be negative 8 e to the negative 2x minus 4y times, again, the derivative of that interior function, and again with respect to y, meaning we'll get negative 8 e to the negative 2x minus 4y, that portion unchanged, and the derivative of that interior function will again be negative 4, giving us a result of positive 32 e to the negative 2x minus 4y. We'll end up with a different result in part C, where now we're taking r sub y x, meaning we're starting with that result from part A, r sub y, and now differentiating with respect to x. So we'll start off with negative 8 e to the negative 2x minus 4y times the derivative of that interior function. What's different, again, keep in mind, is that now we're differentiating with respect to x. the first part of this expression stays exactly the same, and the derivative of that interior function with respect to x will become negative 2 minus 0, or plus 0, doesn't really matter either way. And then we can multiply negative 8 times negative 2 to get 16 e to the negative 2x minus 4y.